Nenomatica, where mathematics meets YouTube excellence. We are going to solve step by step a rational expression multiplication example, and we will follow a clear visual algorithm with rule boxes, highlights, and a final summary. Here is the example. We will solve exactly as written. First, the word example will appear, then the bold orange problem statement just below it. Before we begin, a quick challenge. What factoring step do you predict we should do first? Step 1. Factor and simplify each fraction. We will apply the factoring of difference of squares and factor out common x. Step 2. Cancel common factors in numerator and denominator. Here, the factor x minus 1 cancels, and the factor x plus 1 cancels. Step 3. Multiply the remaining terms. We multiply x squared over x to get x, and then multiply by 4 to get 4x. Quick recap. 1. Factor each part. 2. Cancel common factors. 3. Multiply what remains. Let's display the word example. Then the first problem in bold orange. Problem 1 is open fraction x squared minus 5x minus 14 over x squared minus 3x plus 2 close fraction times open fraction x squared minus 4 over x squared minus 14x plus 49 close fraction. Rule box. Factoring quadratic polynomials. Now, step 1, factor all polynomials. We write the fully factored form. Quick challenge. Can you see x squared minus 5x minus 14 as x minus 7 times x plus 2? Multiplication of fractions. Step 2, write as multiplication of fractions. Now we replace the times sign by a centered dot between two fractions. Cancel common factors. Step 3, cancel common factors. We cancel x minus 2 and one copy of x minus 7. The remaining expression highlights the parts that changed. Multiply numerators and denominators. Step 4, multiply remaining factors. We get the final simplified form for problem 1. Great job! Now let's move to problem 2. Problem 2 is open fraction x squared plus 5x minus 24 over x squared plus 6x plus 8 close fraction times open fraction x squared plus 4x plus 4 over x squared minus 3x close fraction. Rule box. Factoring quadratic polynomial. Factoring quadratic polynomials. Step 1. Factor all polynomials for problem 2. Write each quadratic as a product of binomials. Multiplication of fractions. Step 2. Write as multiplication of fractions with a centered dot. Rule box. Cancel common factors. Step 3. Cancel common factors. Here x minus 3 and one copy of x plus 2. We highlight the changed pieces in orange. Rule box. Multiply numerators and denominators. Step 4. Multiply the remaining factors to get the final simplified form. Excellent work following the structure exactly. Let's summarize. We factored each quadratic, wrote the product explicitly, In this lesson, we will simplify rational expressions by factoring and canceling common factors while carefully tracking each step with clear rule boxes. Let's start with our first example. Then we will present the problem statement in bright orange so it stands out. Step 1. Factor each polynomial expression. We will use the difference of squares and standard quadratic factoring. Step 2. Multiply the factored expressions and simplify by canceling common factors. We use the rule for multiplying rational expressions and then remove factors that appear in both numerator and denominator. The simplified value of the first expression is 1. Quick challenge. Can you predict the next step in the second example before it appears? Let's move to our second example. We will again display the problem in bold orange. Step 1. Factor each polynomial. We use quadratic factoring to write each as a product of binomials. Step 2. Multiply and simplify by canceling common factors. We will remove the common factor x minus 3 first, being careful to remember domain restrictions. Step 3. Cancel one of the x plus 2 factors to simplify further. We again use the cancellation rule, where the common factor is non-zero. Important note, do not divide by 0. The original denominators require x not equal to -2, -4, 0, or 3. So the simplified result is open parenthesis x plus 8 close parenthesis times open parenthesis x plus 2 close parenthesis over x times open parenthesis x plus 4 close parenthesis. Here is our example. First, read the problem. We will start with the first product. Rule: multiply rational expressions. Multiply numerators together and denominators together. Now we write it as one fraction and gather like factors. Next, simplify by canceling common factors in the numerator and denominator. We simplify the constants first, and then simplify each variable's power. Quick challenge. Second product. We will factor each part first. Apply factoring rules, including perfect square, trinomials, and difference of squares. Next, use the sign flip identity, b minus equals -1 times a minus b. Then cancel common factors carefully and reduce the constants. We show the expression will simplify. Factor each numerator and denominator. We will use the difference of squares rule and a grouping method for quadratics. First, recall the difference of squares rule. Apply it to 9x squared minus 16, and also recognize a perfect square for 4x squared plus 4x plus 1. Next, use factoring by grouping for 6x squared plus x minus 1, and for 9x squared plus 9x minus 4. We'll show each factoring line by line. After that, we rewrite the original product in fully factored form. Cancel common factors. Any factor that appears in both numerator and denominator can be removed. Here, we cancel the factor 3x minus 1, one copy of 2x plus 1, and the factor 3x plus 4. We then highlight what remains after cancellation. Finally, we write the simplified result. Quick challenge. Could you have predicted which factors would cancel before expanding the grouping steps? Take a brief moment to reflect. Let's wrap up with a short summary of what we learned. Let us show the example and the problem in bold, orange math. Before we begin, here is a quick challenge. Can you predict our first algebraic move? Step 1. Combine the sum inside the parentheses into a single fraction using the common denominator rule. Step 2. Substitute this result into the original product. Step 3. Multiply the two fractions. Multiply numerators together and denominators together. Step 4. Cancel the common factor. Since s plus our equals are plus s, they cancel from numerator and denominator. Step 5. Simplify the fraction s over our s by dividing numerator and denominator by s. Now we present the final answer in green. Summary. We added the fractions using a common denominator. Here is the problem statement based on the visible content in the image. We use bold orange latex for the statement. Next, a brief OCR and text extraction summary. We identify Latin letters, digits, and symbols and rewrite them in latex. We also translate non-English text to English. From the image, we read a equals x over x minus 1 and b equals x plus 1 over x. Quick challenge. Before we compute, can you predict the simplified form of a times b? Take a moment to think about combining b into a single fraction and then multiplying. Step 1. Use the common denominator rule to write b as a single fraction. We change b equals x plus 1 over x into b equals x squared plus 1 over x. Step 2. Multiply a and the new expression for b using the multiplication of fractions rule. Multiply numerators and multiply denominators. Step 3. Apply the cancellation property to remove the common factor x in numerator and denominator, keeping in mind the domain restriction, x not equal to 0. Step 4. State the domain restrictions from the original expressions. From a equals x over x minus 1, we need x not equal to 1. From b equals x plus 1 over x, we need x not equal to 0. So the domain is all real numbers except 0 and 1. Final answer. The expression for c equals the fraction x squared plus 1 over x minus 1. We show the example and the problem statement in bold orange. Quick challenge. Can you predict the first algebraic move we will apply to isolate the variable a? Step 1. We restate the given proportional relation exactly as extracted from the image. Step 2. We isolate a by dividing both sides by the fraction x squared minus y squared over 4x plus y. Here is a quick nudge. Division by a fraction is multiplication by its reciprocal. Step 3. Apply the division of fractions rule. over b over c equals a times c over b. This removes the complex fraction neatly. Step 4. Write a as a single fraction by moving the factor x plus y into the numerator. We will keep the structure exactly as in the source solution without canceling. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. Nenomatica, where mathematics meets YouTube excellence.